Now in question number 13, we have to prove that this long term on the left hand side is equal to 1. And if you look at the terms on the left hand side, we have terms like cot x, cot 2x and cot 3x. And so our approach should be to get all those terms in similar form, for example in the form of cot x, so that some of those terms get eventually cancelled out and we get the term that we are looking on the right hand side, that is 1. Okay, so let us look at the expressions for cot 2x and cot 3x because we want to convert them in terms of cot x. Now we know that tan 2x equals 2 tan x divided by 1 minus tan squared x. So therefore we can write cot 2x as 1 minus tan squared x divided by 2 tan x. We'll try to get everything in the form of tan x rather than cot x because that will be easier to do. And we also know that tan 3x equals 3 tan x minus tan cube x divided by 1 minus 3 tan squared x, and therefore cot 3x would be equal to 1 minus 3 tan squared x divided by 3 tan x minus tan cube x. So let us get everything in the form of tan x rather than cot x. That might be easier to do here, although we could have attempted to get everything in the form of cot x as well, but right now we'll try to do everything in tan x form. So now LHS here is equal to cot x we'll write as 1 by tan x multiplied by cot 2x, which is 1 minus tan squared x divided by 2 times tan x minus cot 2x, which is again 1 minus tan squared x divided by 2 tan x multiplied by cot 3x, which is 1 minus 3 tan squared x divided by 3 tan x minus tan cube x. And our last term, which is cot 3x, which is 1 minus 3 tan squared x divided by 3 tan x minus tan cube x multiplied by cot x, which is 1 by tan x. Now we can take the LCM as 2 times tan x into 3 tan x minus tan cube x, which we can again write as tan x multiplied by 3 minus tan squared x. So this becomes 2 tan squared x multiplied by 3 minus tan squared x. And in the numerator, in the first term, we get 1 minus tan squared x multiplied by 3 minus tan squared x, and in the second term we have minus 1 minus tan squared x multiplied by 1 minus 3 tan squared x, and in the third term, because we don't have space, let us write that here. We have minus 2 times 1 minus 3 tan squared x. Now we see that in the numerator we have 1 minus 3 tan squared x common between these two terms, and therefore if we take that as common, we'll get 1 minus tan squared x plus 2, which is 3 minus tan squared x, and that is a term we also have in the first expression. So we have a possibility of simplifying this. Let us do that. So we'll write the first term of the numerator as it is, 1 plus tan squared x multiplied by 3 minus tan squared x, and we'll combine the second and the third terms. We'll write that as minus of 1 minus tan squared x plus 2, which is 3 minus tan squared x times 1 minus 3 tan squared x, and the whole thing is divided by 2 times tan squared x multiplied by 3 minus tan squared x. And now we can take 3 minus tan squared x as common in the numerator, and the rest of the term becomes 1 minus tan squared x, sorry, we had a minus here, 1 minus tan squared x minus 1 plus 3 tan squared x, so that becomes 2 tan squared x. And exactly that is what we have in the denominator. We have 2 tan squared x multiplied by 3 minus tan squared x. Therefore, all these terms cancel each other and we get 1, which is the same as RHS. Let us now move on to the next problem. In question 14, we need to prove